Hello, my students in grade 7. This is our mathematics lecture 12, and the title of our lesson is Angles and Lines. What are the objectives of this lesson? First, we will define parallel lines. Then, number 2, identify the properties of parallel lines. Number 3, define perpendicular lines. Number 4, also we will identify or know the properties of perpendicular lines. Number 5, identify alternate interior angles and their properties, and identify corresponding angles and their properties. Parallel straight lines, and we will start. As we know from previous years, what is the definition of parallel lines? When we are talking about two parallel lines in math, we are talking about lines that do not intersect and always have the same distance apart from each others. For example, if we look here, we have line L and line M. Line L is parallel to line M. Since they are apart the same distance, they are far from each other, always the same distance, and they never intersect. Always, if we look at line AB and line CD, line AB is parallel to line CD, since also they never intersect. So the parallel lines are the lines that never intersect with each others. Now, parallel lines properties. What are the properties of parallel lines? Property number 1, if we have any line XY, for example, and we have a point A outside this line XY, how many parallels passing through A can we draw to XY? Through a point, not on the straight line, we can draw only one parallel line to the straight line. So through point A, only one parallel line, which is UV, can be drawn to XY. Now we can say that line UV and line XY are parallel. Property number 2, if two straight lines are parallel, for example, if we have two straight lines D1 and D2 parallel to each others, line D1 parallel to line D2, then if I draw line D parallel to line D2, then I will get these three lines will become parallel to each other. Then D1 is parallel to D2 and parallel to D. So if two straight lines are parallel, then every straight line parallel to one of them is also parallel to the other. These are the properties of parallel lines. Property number 3, if two lines are parallel, then every straight line cutting one of them also cuts the other. For example, if we have line D1 parallel to line D2, if line D cuts D1 and D2, this line is cutting D1 and is cutting D1, then it also cuts D2. Okay, so these are the properties of parallel lines. Now, perpendicular lines, what is the definition of perpendicular lines? They are lines that intersect to form a right angle. Then line M and line N are perpendicular. They intersect at a point, and in between they form four right angles. Then we say M is perpendicular to N, and four right angles are formed in between. What are the properties of perpendicular lines? Property number 1, also if we have a straight line XY and a point A not on the line or outside the line, how many perpendiculars can we draw to XY passing through A? As you can see, passing through A, we can only draw one perpendicular to the line. Property number 2, if two straight lines are perpendicular to a third, they are parallel. For example, if I have a straight line XY, D1 perpendicular to XY, D2 is perpendicular to XY, then D1 and D2 are parallel to each other. So if two lines are perpendicular to the same line, these lines become parallel to each other. Of course, we should never forget to draw perpendicular line, we should use a set square. Property number 3, if two lines are parallel, every perpendicular to one of them is also perpendicular to the other. For example, D1 is parallel to D2. If I draw a line D perpendicular to D1, also if I continue this line, it will be perpendicular also. D will be perpendicular to D2. Now, if I have two parallel lines, X and Y is parallel to UV. So line XY parallel to UV. As we said before, if I draw a line ZT cutting XY, it also be cutting UV. After I draw this line is called a transversal. So any line cutting two parallel lines, we call it a transversal. As you can see, after I draw the transversal, different angles between the transversal and the parallel lines are formed. So here we have angles and here we have angles also. So as you can see, we have angle 1, angle 2, angle 3, angle 4, angle 5, 6, 7, and 8. If we look to the angles 1, 2, 7, and 8, 1, 2, the angles 1 and 2 are outside the parallel lines. Also, the angles 7 and 8 are outside the parallel lines. The angles 3, 4, 5, 6 are inside, so we call them interior. The angles outside, we call them exterior. The angles inside, we call them interior angles. Now let's talk about the interior alternate angles. As I said, the angles that are formed between the transversal and the parallel lines, which are between the parallel lines inside, are called interior angles. So 1, 3, 2, and 4 are interior. But which one are interior alternate? If I look at angle 1, which is to the left of the transversal, and angle 2, which is to the right down on the transversal, angle 1 and angle 2 are equal to each other since these two angles are called alternate interior angles. Also, angle 3 and angle 4 are equal to each other since they are alternate interior angles. And as you know from before, the sum of angle 2 plus angle 3, if we add these two angles, they give me a pair of supplementary angles. They form a straight line. So the sum of 2 and 3 is 180 degrees. The sum of 1 and 4 are 180 degrees. So always any two interior alternate angles are equal. So 1 and 2 are interior alternate, 3 and 4 are interior alternate. Let's take an example. If this angle is equal to 75, so also this will be 75 since these two angles are interior alternate angles. The sum of this angle plus this angle is 180 degrees. So 180 minus 75, I get 105 degrees. Now this angle 105 degrees is equal to the angle 105 degrees. Why? Since they are alternate interior angles. Always I should look to alternate interior angles, as you can see here, as I have the letter Z. So in this angle and this angle, they are equal to each other. These are the interior alternate angles. The corresponding angles, when I talk about corresponding angles, these angles are one interior and the other exterior, but they are on the same side of the transversal. They form an F letter. If you look at the letter here, it's an F letter. So A and B are corresponding. This angle and this angle are corresponding. This inside and this outside are corresponding. So we have too many corresponding angles. I want to ask you something. What do you say about the angle TAY and XAB? This angle and this angle are vertically opposite angles. This angle and this angle are equal since they are vertically opposite angles. So in this figure, we have lots of pairs of angles. We have interior alternate, we have exterior corresponding, we have vertically opposite angles. Also, there are supplementary angles. Their sum is 180 degrees. Any pairs you can have in this. So as I said, here XAT and TAY are supplementary angles since their sum is 180 degrees. XAT and YAB are opposite, vertically opposite angles, and they are equal. So always remember this shape. When I talk about alternate interior, I'm talking about this big with this big on the opposite, the small with the small. If I'm talking about corresponding a big with a big, or a small with a small, a big with a big, or a small with a small, give me alternate corresponding angles. Big and big are vertically opposite, small and small vertically opposite, big plus small supplementary angles 180 degrees. Let's practice this exercise. We have this figure here, as you can see, and we should find all the missing angles. I am given angle TAY is 62 degrees. So directly I can say that XAB, which is vertically opposite, also this is equal. So I say angle TAY is equal to angle XAB, or I can find this angle TAX. If I add XAT plus TAY, supplementary angles, their sum is 180 degrees. So if this is 62 degrees, then this angle is 118 degrees. Now I can find this angle here, which is XAB. Angle XAB is vertically opposite with TAY, so it's equal to 62 degrees. Also, angle YAB is vertically opposite with XAT, so it's 118 degrees. Now, this angle inside is equal to this angle. These are interior alternate angles, so this is 62 degrees. Also, this is 118. Also, these are two equal to each other's vertically opposite, and these are equal to each other's vertically opposite angles. This was our lecture for this week. It's not a hard lecture. I reminded you of information we have taken before. So please watch this video well, and if you have any questions, please contact me. Thank you.